Is Zach Hickson, and today I would like to present to you our CS 4100 project called Snake Game. I made this game with my group members, Chloe Lee and Connor Abramson Tew. The basic idea behind the game is competitive Snake, the classic game Snake, where you play against different AI models. The two options are A-star, which is a search algorithm, and PPO, which stands for Proximal Policy Optimization, which is a reinforcement learning algorithm. We tried a few different approaches for reinforcement learning algorithms. We tried Q-learning and deep Q-learning, but we found the most success with PPO. So I'll quickly demonstrate the game. It's just classic Snake, but you play against AI agents. And whoever has the most apples at the end of the game wins. So this is A-star. This is just a classic pathfinding algorithm. It's quite good on a 20 by 20 board as it has a lot of open space to, it can make a mistake and it won't die. So it gets, roughly 50 to 70 apples per game. Yeah, I won't show it dying here because it will take a little bit before it runs into itself. But yeah, so I will quickly end the game. AI wins. I have 13. AI has 14. And I will show PPO. So this PPO model was trained on 9,000 episodes. I'm still training it in the background as I'm curious to see how good it can get, and I will actually show the training process later on in this video. So this PPO model, it averages maybe like 20 to like 100 apples. It's had some very successful runs, which I will show in a second, and it also has some awful runs where it runs into itself very quickly. But on an average run, it definitely scores, I think the lowest I've ever seen it score is like 16, where it runs into itself pretty early. But yeah, for the reward function, we tried to prioritize a mix of almost everything, of survival, of open paths so that it can escape after getting an apple, and of course getting apples. So we used Manhattan distance, we used BFS to calculate optimal paths, and I think my favorite function of the reward, or my favorite portion of the reward, was calculating the Manhattan distance versus the BFS like optimal route, and if that deviated too much, it makes it unoptimal moves, like not so that it dies, but it's so that it kind of wastes its turn and doesn't just rush in immediately, but it can open up certain paths so that it can get the apple without putting itself in danger, or as I like to call it, greedy. It's not too greedy. So it died there. It was trying to go for the apple, but it hit its own tail. This would be worked out with more iterations, but it takes quite a while to train a 20 by 20 model, as the games last, a very long time. It's much quicker to train on smaller board sizes. So I will end the game, and I will show you our other game mode, actually. So we also implemented a slither mode, which was, the idea stemmed from slither.io. So here we're playing against an A-star model, where we're on the same board, and the snakes can kill each other. So apples don't matter in this mode. It's just, how much space you take up, which allows you to win more optimally. The A-star model is quite good on this board. It's very hard to catch it, and it's easy to make a mistake. So right now I'll try to run it into a wall, but it will escape, just like that. And let's see if I can get it. I don't think I can, though. It's quite good. Okay, and it gets me. All right. So that is PPO. We can play in different board sizes. The smaller the board, the more difficult it is because it moves quite fast. But yeah, so the board options are 10 by 10, 20 by 20, and 6 by 6. And you can play on any of those boards. I'm just going to end this game. But yeah, so let's go back to the classic mode. So for 10 by 10, we made another PPO model. Actually, I'm going to quickly show 6 by 6. This is our most successful PPO model, as it's very easy to train since the board is so small that you can get a lot of plays in a short amount of time. So this model actually beats A-star. I would say this model can average between 15 apples to completing the game. Actually, we've had a few cases where it has completed the game given good apple spawns. So right there, it did die a little early. It trapped itself in. This was our first successful PPO model, so we were still learning the basics of the reward function. But for future models, and I will actually show, we do have cases where we try to avoid the model trapping itself in to get an apple. The first implementation of this was in our 10 by 10 model, so I'll quickly show that. But I would like to show off this model, as it is pretty successful, and again, it is better than A star. You know, as a person, like as a a human user, 6x6 is quite easy since it's difficult to make a mistake, and you can kind of just do the same algorithm over and over again, kind of like what I'm doing. You can win. I did die there, awkward, but it's okay. You have to believe me on that one. Yeah, let's show the 10 by 10 model. So this is again PPO. This was trained for about 20,000 iterations. It's not as successful as our 6x6 model since we just needed a little more time. But the reward function is a little more well tuned in this one, where it does account for how many open spaces it has before it gets an apple. So we've tried to make it a little more careful in its pursuit of growth. And in order to make it more careful, we use a BFS algorithm so that it can determine the most optimal route versus the Manhattan distance. And if those two numbers differ too much, then it actually makes unoptimal moves so that it can open spaces up around the apple, and it can have a safer path there. Again, it did just die, but you have to keep in mind that we did not have the best infrastructure to train these models. We were running on laptops and like laptop GPUs, so it takes a little bit to train them. Same goes for the 20 by 20 model. That one takes quite a while to train versus the 6 by 6 or the 10 by 10, since there's just so many more states. And yeah, so the 10 by 10 model can average between at like a minimum 11 to like 12 apples, and at a maximum it can hit around 50, but that is quite rare. There has to be some good apple spawns. But I believe that given enough time, this reward function and with using PPO, it could beat the 10 by 10 board, but we have not seen it happen yet. We did stop training this model to focus more on a 20 by 20 model, as we wanted to include a PPO for that as well. So that is where most of the time is gone. And yeah, I'm going to quickly show you a successful run. So if we go to our other page, which is the model dashboard, we can see a currently training model here. As you can see, there's a graph of rewards. I'll quickly break this down a little more in a second, but I just wanted to show off the best replay. This is quite a successful replay. So this is our gym environment. We called it model training dashboard so that we can accurately see how the model's doing at a given time. This has come in very handy with training the models for the Snake game. The first thing we implemented was a graph that just shows the average reward over a given amount of time. So as you can see here, it started at episode 94, which is the top number. It scored an average reward of negative 0.616, so not very good. Every 10 seconds, we send a query to the train.py function, which has endpoints to report back to the front end with how the model's doing at a given time. We can make it faster than 10 seconds or slower than 10 seconds. That's a customizable field. And yeah, so as you can see, it started off with like pretty bad average rewards, but this was only train 737. And it went up and up and up until at around 4,000, it really started to get it. And it understood that, it has to go after the apple without running into walls. And yeah, it converged to around like 45-ish. It kind of jumps back and forth. It oscillates. But yeah, we're seeing constant improvement. So our most recent data point at 21,000 has an average reward of 45. The next most recent has 41. So, it fluctuates. The ability of the pause button, resume button, and stop button have come in very handy as well. When someone wants to free up their computer, if they want to do something else, you can always just pause the model and come back to it, and then you can resume it once you're back, or you can stop it if you're ready to be done with training. And my favorite functionality is the show best replay. This has come in very handy with determining how the reward function is affecting the model performance. And as you can see, you can very well see what the model is doing at its best replay. So the way this works is we capture the moves the model makes, and if it scores a higher reward than what we've seen so far, we store those moves in an array, and we are able to send it to the front end when this button is clicked and just display it. A way that this has helped us is at the very beginning, we saw that the model was a little too greedy when it came to eating apples, and it would trap itself in positions when it got pretty long. So we added in functionality to determine which squares have like open spaces. It's called the flood fill algorithm, using BFS. So a BFS flood fill algorithm. And this helped the snake make better decisions at longer lengths. So we also added in a ratio of available squares to snake length to make the flood fill algorithm worth more like reward points the larger the snake got, which encourages safer behavior, so that it can live longer and eat apples in a way that is less dangerous to itself. So as you can see, the longer it gets, the safer it will also get, which has come in very helpful. And yeah, this is our model training dashboard.